Yes, sir.
So in last class we did electric field is zero equilibrium position or null point due to two positive charges. Okay, I think that
Yes,
was
sir.
question number 25.
Yes, sir.
So we'll start off with question number 26. And today we will take one positive charge. Let us say at point A we have a positive charge plus Q1, and at point B we have a negative charge minus Q2. Okay.
Yes, sir.
So along the extended line joining A and B, okay, so along the extended line joining AB, joining A and B, find, we can say equilibrium position, or we can say find a point where the net electric field is zero. Okay.
Yes, sir.
So find the point or points where the net electric field due to both the charges is zero. Okay,
Yes, sir.
fine. One is a
Yes, sir.
positive charge, other is a negative charge. In field lines, we already discussed that in between these 2 points, the electric field is never zero and it is in this direction, right?
Yes, sir.
Okay, from left to right. So I can
Yes, sir.
have null vector, null point where the net electric field is zero, either on the left
Absolutely
side
right.
or right side.
Yes, sir.
Okay. So let us take, let let C be the point where such that the electric field, net electric field at point C is zero. Okay.
Yes, sir.
Let the distance between AB be given as A, and here let us take this distance AC as X. Right?
Yes, sir.
The direction of electric field due to charge Q1 is going to be from right to left, away from positive
Yes,
charge.
sir.
Whereas the direction of electric field due to charge Q2, which is E2, will be from left to right, which is towards
Yes, sir.
right. For the net electric field should be equal to zero. That means the electric field magnitude E1 should be equal to the electric field of magnitude E2.
Yes, sir.
Now, what is electric field E1? K
KQ1 by X square.
by
No.
x
Yes,
square
sir.
is equal to K Q2 by
KQ2 by A plus X whole square.
A plus x whole square. Now, again, here cross multiplication, solving just like what we have done in the previous lecture. So, A plus x divided by x whole square is equal to Q2 by Q1. Fine.
Yes, sir.
So I'm writing directly, I'm writing A by x plus 1 is equal to under root of Q2 by Q1. Okay.
Yes, sir.
So therefore I can write A by x is equal to under root of Q2 by Q1 minus 1,
Yes, sir.
implies therefore basically x is equal to cross multiplication. I can write it as A by under root Q2 by Q1 minus 1. Is this clear?
Yes, sir.
Again, here you can say there is plus or minus when I take the under root.
Yes, sir.
If I take it as minus, then this will be minus. I will get x as negative,
Hmm.
which will come in between a and b according to my diagram,
Hmm.
which is not possible.
Yes, sir.
Xerox. So when we started electric field due to point charges, we have done find the electric field due to two charges or three charges at the vertices of a square at the
Yes,
fourth
sir.
vertex. We have done those things, right? E1
Yes,
I
sir.
cap, E2 J cap, and one more thing will come in terms of I cap plus J cap by root 2.
Hmm.
Oh, in fact, we have also done the rectangle thing. General,
Yes, sir.
taking the length as L and breadth as B, we figured out that this is L comma 0, that is 0 comma B, and that is L comma B, right?
Yes, sir.
So electric field due to this one, that one, everything in terms of L, B, theta, right?
Yes, sir.
So we've done all those things. I'm just trying to figure out if there is something that needs to be done. Okay. So, 27.
7.
So, fine. So now I'll do some important and common questions which are there in our JE stuff. Okay.
Yes, sir.
Now here till now, like whatever, like that stability thing lecture which we discussed, I said that was important, right?
Yes, sir.
Similarly, this is also more or less the same level of importance, okay, which is again discussed in everywhere. Okay, 27. And also this is one type of HCV problem also. Okay.
Hmm.
So eventually when we'll solve HCV, you will come across the same thing. Now take a look. So what that fellow says is that let 2 point charges be attached to two ends of uh, be attached to ends of two silk threads. Silk threads, why we use is basically it should be a non-conducting kind of a thing. Okay. So
Because it's massless almost.
yeah, we can say that also. Both massless and charge conduction doesn't take place. So here is the story. So there are two strings, non-conducting massless strings. Okay. And I have two charges
Hmm.
attached to ends of these strings. Okay. Two charges,
Yes, sir.
equal charge, or let us say two identical charges. Okay. When we say identical charges, what does that mean? The charge and mass are the same. Okay. So we
Yes,
have
sir.
two identical charges, meaning that the charge on each and the mass on each is same. Fine.
Yes, sir.
And these two non-conducting strings are fixed at a single point. It is given that the length of each string is L. Now,
Yes,
what is
sir.
going to happen? When you leave these two charges, electrostatic force is going to be applied on either of the charges in opposite direction, right, due to each other. Correct?
Sir, how do we know it is opposite?
Because like charges repel each other.
They give like
Two identical charges,
yes, sir.
and each having a charge of plus q. Okay.
Yes, sir.
So there will be a repulsive force on each other due to each other.
Yes, sir.
So the charges are not going to remain at this position. Eventually, they will go farther from each other, right?
Yes, sir.
Clear?
Yes, sir.
So how are they going to look like? They will look like something like this. They'll go apart from each other, right?
Yes, sir.
Let us say at equilibrium, let us say at equilibrium, both the charges are at a distance of 2a from each other.
Yes, sir.
Both the charges are at a distance of 2a from each other. This is the sealing point. Okay. And both the charges are at a distance of 2a from each other. The length of the string is going to remain the same, right?
Yes, sir.
When I say equilibrium, what do we mean by equilibrium? That means this charge and this charge is basically right now at this position. The net force acting on them is zero. Is this clear?
Yes, sir.
Fine.
Yes, sir.
So first we have to identify what all forces are acting on these charges, right?
Mm.
So in this case, I will take one is electrostatic force due to the other charge
Yes, sir.
away from the other charge, correct?
Yes, sir.
Another is gravitational force, correct?
Yes, sir.
Is there any other force acting on it?
Centripetal.
Just because just because I know English doesn't mean
Tension. Yes,
I
sir.
should be using it randomly, right? Tension force, right?
Yes,
See,
sir.
so this is where that's why I am a little bit excited also to discuss these things. Because these are, even though they are common questions that are discussed, most people get confused. Okay,
Yes, sir.
most people have some problem or the other in solving these type of questions. Now, what is the problem? Problem is simply the step by step approach of how to solve it. Okay,
Yes, sir.
understand what is the question first. In the question, he has given you a story where there are two insulated threads, okay,
Yes, sir.
which basically cannot be charged or no conduction takes place, okay.
Yes,
And
sir.
these threads are both attached at a fixed point on the ceiling.
Yes, sir.
The other end of these strings are attached to charges, or let's say two identical charges are attached to other ends of the strings, each having a charge plus q and mass m. Clear?
Yes, sir.
When we say identical charges, automatically we mean that the charge and mass is same. Okay.
Yes,
When
sir.
we use the word identical, it's understood that the charge is same and the mass is same. Okay.
Yes, sir.
So that is what that is given to us. Two positive charges having charge q and mass m each are placed in this particular situation. That's it. Then he will ask you, at equilibrium position, how far from each other will they be? Or what will be the angle that they make? And all these situations. Okay.
Yes, sir.
What we have to understand is step by step procedure of what is going to come up, right? If you
Yes,
leave
sir.
it like this, what is going to happen? Electrostatic force is going to act in the opposite direction on each of the charge, correct? Which will
Yes,
take the
sir.
charges away from each other.
Hmm.
Is this clear?
Yes, sir.
Now, as it is taking the charges away from each other, there will be a situation, there will be a position, something like this, where both the charges are at equilibrium position.
Yes, sir.
What is this equilibrium position?
Yes,
Equilibrium
sir.
position, when I mention, that means the
The net force is
net force
zero.
is zero. When I say equilibrium position, that means I am saying the net force acting on either of the charges is going to be zero. Is this clear?
Yes, sir.
So when reading the question, I understood how the charges are placed and how the figure is given. Okay, point number one. Point number two, I have also understood that this fellow is interested in discussing something about equilibrium position. Fine.
Yes, sir.
Now, what he is asking me, maybe he is asking me, find this, so there will be symmetry, right?
Yes, sir.
So maybe he is asking me, find this angle theta, or maybe he is asking me, find the distance A.
Yes, sir.
So he is asking, maybe he'll ask me something, but one thing is for sure that he is talking about equilibrium position, correct?
Yes, sir.
When he is talking about equilibrium position, that means we are saying that the net force acting on each charge is zero.
Yes, sir.
That means I should be interested in the forces which are acting on the charges.
Yes, sir.
Is this clear?
Yes, sir.
So till here I don't know how to solve it. I just am trying to interpret and understand what that fellow has given information, and from that information I am trying to figure out how I can proceed.
Yes, sir.
Kahani mentions equilibrium position. That's enough for me. That means you are talking about net force is zero. That means you are interested in forces acting on charges. Is this clear?
Yes, sir.
Now, when I come over here, what are the forces that are acting on the charges? Obviously, we are in electrostatics chapter, so we electrostatic force should be there, right?
Yes, sir.
Then he has given mass. So that also means that there is some kind of a gravitational force acting on it.
Yes, sir.
Another point, suppose if I don't take gravity, then there is nothing to solve over here, right? Both the charges will go away from each other maximum,
Yes, sir.
and that 2a will become 2l,
Hmm.
correct? Is this clear?
Yes, sir. Yes.
The 2a distance between the charges will be
Yes,
nothing
sir.
but 2 times of L.
Yes, sir.
Is this clear?
Yes, sir.
So if there is equilibrium position somewhere in between, then my intuition should tell me that there should be some kind of gravitational force also acting here. Okay.
Yes, sir.
Now, I do understand that centripetal word is not correctly installed in your head. So leave that word for now. I will explain it whenever it comes. But I am trying to see if there is any other force which is possible. And because there is a string attached, I should have tension force, right?
Yes, sir.
Is this clear?
Yes, sir.
Okay. Now let us draw the free body diagram. In the free body diagram, I am showing this is the tension force. This is the vertical line. This angle will be theta, correct?
Yes, sir.
This is my electrostatic force and this is downward is my gravitational, correct?
Yes, sir.
Now, at equilibrium, the first step of any question when you're solving is the important step, always. If I get the initial steps correctly, then solving even a ninth class fellow can do it.
Yes, sir.
So the first steps is where I have to be very careful. So when I say equilibrium position, that means the net force over here is 0. So what I will do is that I will take components of tension force. In this direction, it will be T sine theta. In this direction, it will be T cos theta, correct?
Yes, sir.
The upward force T cos theta should cancel the gravitational force, correct?
Yes, sir.
And the right side force T sine theta should cancel the electrostatic force. Is this clear?
Yes, sir.
You must have seen these equations many times in classes also, right?
Yes, sir.
But the problem is nobody actually asks, how can I write these equations like this?
Understood.
You understood how I can write?
Yes, sir.
Explain.
Sir, the net force is 0. That's why the, I mean, one component is, both of them are in opposite direction if we take along y-axis. So the t cos theta will be equal to mg in order to
Let
be
us go. Let us go in a slow motion. I am a weak student. I am not as fast as you are. So you said because it is equilibrium position, the net force is 0, correct?
Yes, sir.
Okay, I understood that. For the net force should be equal to 0, what you said is along x-axis and y-axis, the forces should cancel each other, correct?
Yes, sir.
I have a problem over here. Why should I cancel along x-axis, y-axis? I will cancel along a crossed line along the string in the direction of tension. So I will basically say this angle will also be theta, right?
Yes, sir.
Why should I take t cos theta, t sin theta? I will take mg cos theta and fe sin theta and equate it to tension. Why should I not write it like that? Is there any rule somewhere Prime Minister Modi has said along x-axis, y-axis you have to take, otherwise
Yes,
Democrat?
sir.
No, right? So why should I will take mg cos theta, I will take fe sin theta.
I don't know.
That's why I said this is where people face a lot of problem, is because usually people don't tell and also students don't ask. It's a genuine question, right? Why should I take t cos theta, t sin theta? Net force should be 0. Great. I am liking it. Then I will take component of mg and fe, right? Why am I taking components of tension?
Even I wanted to ask, sir.
Correct, right? Is this clear?
Yes,
Question,
sir.
doubt is clear, right?
Yes, sir.
Now here is the sequence. Simple, see, that's why I say if you look at it in layman perspective, you will understand how the scientists have come up with these equations in the first place. Okay, now understand this. Electrostatic force is a force by nature it is available, right? If you have two charges, you have electrostatic force on each other.
Yes, sir.
Gravitational force is also by nature.
Yes, sir.
Only when the distances are different, masses are different, charges are varied, only then the electrostatic forces and gravitational forces will vary, correct?
Yes, sir.
In this case, if I already know distance is something like 2a, then the electrostatic force that it will be there will be a function of a, correct?
Yes, sir.
Similarly, if we are on Earth and mass is already given, mg
R
is
square
also a
is there.
fixed thing.
Yes, sir.
Both gravitational force and electrostatic forces over here are basically natural in nature, right? They are generated naturally. The only force which is generated due to these two forces is my tension force.
Yes, sir.
So here my electrostatic force and gravitational force, they act as action forces. Is this clear?
Sir, action versus that.
Correct. Good question. What is an action force? Action force is a primarily independent force which acts just due to the nature of signs that is existing.
Yes,
Electrostatic
sir.
force and gravitational force are present. These forces are present because of nature by itself, literally nature by itself. We have
Yes, sir.
gravitational force mg and we have electrostatic force between two positive charges, Fe. These are available by
Yes, sir.
automatically, right? Independently. These
Sir,
forces,
then if we consider an inclined plane, there we take components of mg.
when we will discuss inclined plane, I will definitely come over there.
Yes, sir.
Okay. So for now, let us keep that part aside because the concept is the same. I am coming to the concept which matters the most.
Yes, sir.
Okay. See, you asked me what is action force. Action force is a force which is an independent force. These forces are not generated because of some other force, right?
Yes, sir.
Electrostatic force is a fundamental force, gravitational force is a fundamental force. These forces are present in nature and are not generated due to some other third party force, correct?
Yes, sir.
The other force which is present over here, which is the tension force, I can call it as a reaction force, right?
Yes, sir.
See, try to imagine it in this particular situation. Suppose I am increasing the charge, the electrostatic force will increase.
Yes, sir.
Suppose I am increasing the mass, the gravitational force will increase.
Yes,
When the
sir.
gravitational force increases, the charges will come closer. When the
Yes,
electrostatic
sir.
forces will increase, the charges will go farther. Is this clear?
Yes, sir.
Simply in terms of theta, if I have to discuss, if you increase mass, theta will decrease.
Yes, sir.
If you increase charge, theta will increase.
Theta will increase.
So what actually is happening is, for a given charge and for a given mass, the electrostatic force and gravitational force at a distance of 2a from each other, these forces are fixed.
Yes, sir.
The other third force, which is the tension force is developing itself based on these two forces.
Yes, sir.
That's why we are calling it reaction force.
Yes, sir.
Is this clear?
Yes, sir.
So your brother is excited, comes, pulls your hair. Action force. What comes next is reaction.
Yes, sir.
Reaction is dependent on action.
Yes, sir.
Slow pull, slow reaction. Big
Yes,
pull,
sir.
big reaction. Scary reaction, right?
Yes, sir.
Tension force is developing itself based on the magnitude of the electrostatic force and the gravitational force.
Yes, sir.
Is this clear?
Yes, sir.
Now I will make a very important statement. The tension force is generated in such a way such that the components of the tension force cancels the action force. So now let us
Yes, sir.
go a little bit slow about it. If you look at electrostatic force and gravitational force as two different scenarios. So if only electrostatic force is there, who is the sole person who is basically cancelling it? D sine theta.
Yes, sir.
If only gravitational force, if you look at it, the sole person who is cancelling it is T cos theta.
Yes, sir.
Correct? And
Yes,
this
sir.
T is developing itself, even theta, T and theta, both of them are developing themselves in such a way that the components of this tension force cancel the action.
Yes, sir.
So why I took the example of your brother is exactly the same. The reaction force is dependent on the action force such that it doesn't occur next time. Equilibrium is established.
Yes, sir.
The reaction force is adjusting itself, creating itself based on how much the action forces are acting. Is
Yes,
this
sir.
clear? Understood?
Yes, sir.
Now I'll
Yes, sir.
make a statement, okay, which I'll dictate once you write the entire solution. So, what is the original conceptual state? The reaction force will generate itself in such a way such that the components of the reaction force cancel the action forces at equilibrium position.
Yes, sir.
Is this clear?
Yes, sir.
The reaction force is adjusting itself. It's a variable depending on the action forces. Action force are fundamental forces. Electrostatic
Yes,
force
sir.
and gravitational force, both the forces are action forces which are fundamental forces. But the tension force is a force which is generated on the basis of these actions.
Yes,
So the
sir.
reaction force always generates itself in such a way such that its components cancel the action force.
Yes, sir.
Also, why am I taking the electrostatic force independently and gravitational force? Why am I looking at it as independent scenarios? Because the component of any vector in its perpendicular direction is zero.
Yes, sir.
When we are talking of electrostatic force, how much gravitational force is there is not an important issue. And when I'm focusing on my gravitational force, how much electrostatic force is there is not an important issue, right?
Yes, sir.
Because the component of a vector in its perpendicular direction is going to be zero.
Yes, sir.
Is this clear?
Yes, sir.
So therefore, these equations emerge. T sine theta is equal to Fe and T cos theta is equal to mg.
Mm.
That's the reason I am taking the components of reaction force rather than taking the components of action force.
Yes,
I
sir.
told you what was the doubt. I said I'll take mg cos theta, Fe sin theta. Why can't I take it? Because they will become the components of action force.
Yes, sir.
So why should I not take the components of action forces? Because action forces are not adjusting according to the tension force. Tension force is adjusting according to the action. Is this clear?
Yes, sir.
Such that the components of the tension force cancel the action forces.
Yes, sir.
Clear?
Yes, sir.
So therefore, from this equation, you already know the solving of it. We can divide these equations and write tan theta as Fe by mg, correct?
Yes, sir.
Or we can also do square of them and add, right? So let us say if I do t sine theta whole square plus t cos theta whole square will be what?
P.
T sine theta
P
is
square, sir.
Fe square plus mg square, correct?
Yes, sir.
But you can already see if you take t square common, sine square theta plus cos square theta is 1,
Yes, sir.
right? If I take t square common, I'll have sine square theta plus cos square theta is equal to 1,
Yes, sir.
right? So I'll get the equation like this. So basically, I can directly write tension is under root of Fe square plus mg.
Yes,
Is this clear?
yes, sir.
So if he'll ask me what is the tension in the string, I got the tension in the string. If he'll ask me what is the angle theta, I got the angle theta also from here. Correct?
Yes, sir.
Also, if he will ask me what is A, right? How
Yes,
far
sir.
from each other is the equilibrium position? A is nothing but I can write it as L sine theta, right?
Yes, sir.
Do you know how I can write sine theta in terms of tan theta? Trigonometry. Sine theta in
Yes,
terms
sir.
of tan
Yes,
theta.
sir.
How will I write?
Sir, we can write sine theta equal to 1 minus cos square theta. Then if we divide by
I'll write it directly over here. Okay. We need to remember these identities. It's important for our
oh,
solving.
that one, sir, tan 2 theta. Okay, like that.
Tan theta divided by under root of 1 plus tan square theta.
Yes, sir.
Okay.
Sir,
Because
I was telling to do that. I was telling the derivation, but
this entire thing will become
I
what?
finally get that.
Secant theta.
Yes, sir.
And in numerator also in tan theta, if you'll see, sin theta into secant theta will be.
Yes, sir.
Secant will cancel each other. We'll get sin theta, right?
Yes, sir.
So simply I get L sin theta. So I can substitute L times tan theta divided by under root of 1 plus tan square theta. Is this clear?
Yes, sir.
So if I want A, I can get A. If I want theta, I can get theta. If I want tension, I can get tension. But how I am getting these equations and why I am getting these equations are very important.
Yes, sir.
Is this clear?
Yes, sir.
Xerox.
Sir, before we used to take components for the electric field and all, no, sir, to calculate it.
Before we used to take what?
Components for the electric field.
My suggestion is do not confuse yourself in components. In terms of components, this kind of a question with any other kind of a question. Okay. Leave any other question
Yes,
aside.
sir.
Make sure that you understood what is happening here. Okay.
This is fine, sir.
Because many places we do many things and there is a concept behind it. The concept everywhere is vectorial concept and it is the same. But it's very easy for us to confuse ourselves. So here we are given two charges and two masses. So I know fundamentally electrostatic force and gravitational force are acting. The reaction force is the tension force which will act against these action force in such a way that it adjusts itself in such a way such that the components of the reaction force cancel the action forces. Right? Let me know when
Yes, sir.
let me know when you're done because I need to dictate that. Okay. 28, right?
Third statement.
Hmm. Right. Note. The reaction force. The reaction force. The reaction force generates itself. We can also say manifests itself, but manifest becomes a lot of YouTube. So generates is fine. The reaction force generates itself in such a way that the components generates itself in such a way that the components of the reaction force that the components of reaction force components of reaction force cancel the action forces cancel the action forces at equilibrium.
Yes, sir.
Put a star mark near this note. You can also write example, my brother and my hair, for better understanding. So try and understand this concept in general. The reaction force generates itself in such a way that the components of the reaction force cancel the action force, right?
Yes, sir.
The components of reaction force cancel the action force, because action force is basically a fundamental force which is generated due to science that is prevailing, right, which is existing, and the reaction force is generating based on these action forces which are there.
Yes, sir.
And we are using the word cancel because we are talking of equilibrium. The
Yes, sir.
components of reaction forces cancel the action forces at equilibrium.
Yes, sir.
Other than equilibrium, they will not exactly cancel, but they will oppose the action forces.
Yes, sir.
They will act opposite to the action forces. But at equilibrium means they are cancelling the action.
Yes, sir.
Okay, so the procedure should be in our head. The procedure should be registered in the correct fashion. The reaction forces are generated on the basis of the action forces which are acting, and the
Yes,
words
sir.
in themselves also get the same meaning, right? Action, reaction. And Newton's third law is also the same.
Yes, sir.
So the reaction force is generated on the basis of the action forces which are acting in such a way, the reaction force generates itself in such a way that the components of this reaction force will cancel those actions.
Yes,
That's
sir.
the reason I am taking the component of reaction force rather than components of action forces. Is this clear?
Yes, sir.
Understood. Did you put a
Yes.
star mark over there?
Yes, sir.
Okay. 28.
7.
27.
7. Yes, sir. No, no, 28.
Good morning. Now, similar type of question. Okay. So there are two insulated rings. By saying insulated, we are basically trying to understand that there is no conduction through it. Charges will not flow through it. Okay.
Yes, sir.
Because if I take a conducting wire, then the charge, when I say charge Q is placed at one end, the charge will tend to run away, right?
Yes, sir.
Okay. So two insulated strings, and also we will say inextensible strings, right? Two
Yes, sir.
inextensible insulated strings. Okay, but in this question, let us fix the top ends of these strings at a distance of a away from each other.
Yes, sir.
Okay,
Yes, sir.
now string has a length L and the charge which is attached is basically charge Q and having a mass M. Okay.
Yes, sir.
Again, here also we are saying two identical charges. Identical charges in the sense both the charges will have same charge and same mass. Clear?
Yes, sir. Yes, sir.
Two identical charges, each having a mass M and each having a charge Q. Clear?
Yes, sir.
Both are positive charges. Now, what will happen when you leave it like this? Both the charges will go away from each other, right?
Yes, sir.
Is this clear?
Yes, sir.
Because of identical charges, I can say that the angle theta that comes
Will be
out
same.
will be same. Is this clear?
Yes, sir.
Now, let us understand what is the distance between them. This is important, right? What is the distance between them? Because
Electrostatic.
from
Yes,
there
sir.
only I'll get the electrostatic force.
Yes, sir.
So let the distance between them be 2b. Okay,
Yes, sir.
correct.
Yes, sir.
So if distance between them is 2b, how can I write this 2b in terms of a, L and theta? 2b is equal to first a plus, right? Okay.
Yes, sir.
What will this distance be each? L sine theta.
Yes, sir.
Is this clear?
Yes, sir.
If this is L sine theta, even the other side will also be L sine.
Exciting.
So my 2b will be equal to A plus 2L sine
Exciting.
theta. Is this
Yes,
clear?
sir.
Fine.
Yes, sir.
Next, we want to draw the free body diagram, right?
Yes, sir.
FBD. So according to FBD, what will I show? There is a tension force, right, in that direction, and there
Yes,
is an
sir.
electrostatic force in this direction, and there is a gravitational force in this direction. Correct?
Yes, sir.
So there is an electrostatic force in this direction, there is a gravitational force in the downward direction, and there is a tension force in this direction. And because we took that angle as theta, automatically this angle will be theta. Correct?
Yes, sir.
Because if we draw a vertical line, this angle will also be theta.
Mm.
Now you already know why I am taking the components of tension, because it is the
Yes, sir.
reaction. So basically we will have T sine theta is equal to electrostatic force, and T cos theta is equal to
MG.
gravitational force. Here I just want to write electrostatic force can be written as kq square by 2b whole square, correct?
Yes, sir.
Distance between them whole square. That's the reason I have written the first equation.
Mm.
Fine.
Yes, sir.
Now using these entire information, I can get tan theta is equal to
FE by MG.
Fe by mg. This is the first thing. And the other thing I can write tension force is equal to under root of FE square plus mg square, right?
Yes, sir.
Only difference over here is geometry. From the previous question, the difference here is just the geometry part of it, right?
Yes, sir.
Is this clear?
Yes, sir.
Xerox.